Hi, Assalamualaikum and hello everyone. I'm Ahmad Ikon Alif from F1T3. I'm going to present tutorial question chapter 3 periodic table, which is question 14. Okay, elements sodium, aluminium, phosphorus, chlorine and argon are in period 3. Select the element that has the highest melting point, forms diatomic molecular gases, has the highest second ionization energy, forms amphoteric oxide, and write the equation to show its amphoteric behavior. Actually, this question is quite easy, so I think all of you can answer this question very well. Go through question A. Select the element that has the highest melting point. So here is the element in the period 3. The melting point for sodium is 98 degrees Celsius. For aluminium, 660 degrees Celsius, phosphorus 44 degrees Celsius, chlorine negative 101 degrees Celsius, and last argon negative 189 degrees Celsius. So if we in doubt, we can sketch the graph. Here is my graph. We compare with sodium, aluminium, phosphorus, chlorine, and argon. So the answer is aluminium. Aluminium is the highest melting point. The answer is aluminium. Next, question B. Select the element that forms diatomic molecular gases. The answer is chlorine. Why we choose chlorine as the answer? Okay, here is my explanation. Chlorine located in group 17. Group 17 known as halogen. Halogens form diatomic molecular gases. Here is another diatomic element, which is hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. So, question C. Select the element that has the highest second ionization energy. First, okay. Second ionization energy is the minimum energy required to remove an electron from a positive gaseous ion. So first step, we must write down electronic configuration for each element. So for sodium, we get 1s2, 2s2, 2p6, 3s1. Aluminium, 1s2, 2s2, 2p6, 3s2, 3p1. Phosphorus, 1s2, 2s2, 2p6, 3s2, 3p3. For chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. For argon, 1s2, 2s2, 2p6, 3s2, 3p6. So to determine the highest second ionization energy, we refer to the meaning of second ionization energy. Okay, the energy required to remove an electron. What will happen if we remove the electron? So here is the ion of sodium. 1s2, 2s2, 2p6 and remove 1 electron. Same for aluminium. 1s2, 2s2, 2p6, 3s2 and we remove 1 electron. Phosphorus 1s2, 2s2, 2p6, 3s2, 3p2. We remove 1 electron. Chlorine 1s2, 2s2, 2p6, 3s2, 3p4. We remove 1 electron. Argon 1s2, 2s2, 2p6, 3s2, 3p5. We remove 1 electron. The answer is sodium. Sodium has the highest second ionization energy. Why? Why we choose sodium? So here is my explanation. Okay, sodium, the ion of sodium, okay, fully fill 2p orbital with electron. P holds up to 6 number of electrons in the orbital. So that's why we call it as fully filled. And then Na plus ion has octet electron configuration, which is this is octet. Okay. On losing one electron, it requires stable noble gas configuration, Na 1s2, 2s2, 2p6, and thus it gets difficult for the loss of second electron, and the second ionization energy of sodium is very high. Okay, why we didn't choose phosphorus as the answer? Phosphorus has uh, half filled. Half filled. Why it is half filled? Because P holds up to 6 number of electrons in the orbital, but this is only two. Same with chlorine and also same with argon. Okay. The question is natrium and aluminum has the fulfilled electron. Why we still choosing sodium for the answer? Okay. So we must back to the basic. The meaning of ionization energy across a period. This is period 3. So the effective nuclear charge increase, the atomic size decrease. Okay. Electrons are held tightly to the nucleus, thus it is difficult to remove the first electron. Therefore, the first ionization energy is high. It can be said that the first ionization energy increased from left to right. So from left to right. So from left to right. Sodium and aluminum. So we must choose sodium as the answer because we say it can be said that the first ionization energy increased from left to right. So from left to right, so the answer is still sodium. So that's why the sodium is the answer. So that's why sodium has the second highest, has the highest second ionization energy. Okay, D, for question D, select the element that forms amphoteric oxide and write the equation to show its amphoteric behavior. So here is aluminum is amphoteric oxides. Here is reaction with acid, and here is reaction with base. Okay, I think that's all the presentation of me. So thank you very much.
Hello everyone, my name is Divya. I'm from F1T3 and today I'm going to discuss about objective questions 1 until 4, chapter 3 chemistry. So come on, let's read the first question. Identify the element with the highest melting point, and the correct answer is silicon compared to aluminium, magnesium and sodium. This is because silicon is a metallite with a giant covalent structure and has a very high melting point and boiling point because all the silicon atoms are held together by strong covalent bonds which need a very large amount of energy to be broken. Moreover, the stronger the attractive forces are, the more energy is needed to overcome them and the higher the melting point or boiling point. And number 2. Which of the following groups contains a basic, an amphoteric and an acidic oxide? And the correct answer is B. Magnesium oxide, aluminium oxide and sulfur oxide. As you can see, the magnesium is in the basic group, the aluminium is in the amphoteric group, and the sulfur is in the acidic group. And come on, let's check the other answers. We cannot choose the other options because in option A they gave chlorine which cannot react with oxygen, and in option D they gave only basic and amphoteric elements, and in option C they gave silicon. We cannot choose silicon. We cannot choose silicon oxide as acidic or basic because silicon dioxide has no basic properties. It doesn't contain oxide ions and it doesn't react with acids. Silicon dioxide doesn't react with water because of the difficulty of breaking up the giant covalent structure. Next question. Which of the following arrangement shows the order of increasing ionic radius? And the answer is A. We can determine the answer using the variation in the ionic radii across period 3. As you move across a row of period 3 of the periodic table, the proton number and effective nuclear charge increase across period and causes the ionic radius to decrease from sodium to silicon. And in non-metals, the proton number and effective nuclear charge increase across the period and causes the ionic radius to decrease from phosphorus to chlorine. The increase in ionic size from silicon to phosphorus is due to the presence of an additional electron shell in phosphorus. This causes an increase in screening effect, and as a result, the ionic radius increases. And let's move to the next question. The table shows the first, second, third and fourth ionization energies of element Y and Z. Which of the following statements about Y and Z are true? And the answer is all the statements above are true. Let's check it out. First statement shows that the size of Y atom is smaller than Z atom. And how can we determine the size of atom using the ionization energy? Look at the table and see the first, second, third and fourth ionization energies. The higher the ionization energy, the lower the distance between nucleus and the valence electron. So we can clearly see that the Y atom has the highest ionization energy, so it is the smallest, compared to the Z atom which has the lowest ionization energy. Come on, let's check the second statement. Both elements can form ions with positive 2 charge. We can see that there is second ionization energy in the table which took place to remove another electron from the atom. So the second statement is true. Let's see the third statement. Both elements belong to the same group. How to determine that the both elements belong to the same group? So, for that, we have to calculate the ratio of the ionization energy. And these are the steps to calculate the ratio of the ionization energy. You have to divide the first ionization energy by the second ionization energy, and the second ionization energy by the third, and the third ionization energy by the fourth. Then calculate their ratios and compare them. As you can see, the third ionization energy divided by the second ionization energy have the highest ratio. Thus, the third electron is removed from inner shell, so Y atom has two valence electrons. This concludes that Y atom is in group 2 because the valence electrons is 2. We do the same steps to determine the group of Z atom. The calculation shows that the third ionization energy divided by the second ionization energy has the highest ratio. Thus, the third electron is removed from inner shell. So, Z atom has two valence electrons and is in group 2. And that's all from me, and thanks for watching.
Hi guys, my name is Nurul Shahida. So today I'm going to present objective question number 5 until question number 8. So let's go. Question number 5. The atomic radius of the D block elements do not change significantly because 1 Roman, the effective nuclear charge do not change much. 2 Roman, the electrons are added into an inner D orbitals. 3 Roman, the screening effect increases. But what is the atomic radius? Atomic radius is the measure of size of its atom. It has two factors. The first factor is the effective nuclear charge, also known as ZeV. ZeV is equal to Z minus S, which is Z is the proton number and S is the inner electron numbers. The second factor is the screening effect, which is also known as shielding effect. Let's move on to the example to know more about this factor. The first example is an A which have 11 proton numbers. The electronic configuration is 1s2, 2s2, 2p6 and 3s1. Its inner electron is 1s2, 2s2, 2p6 as I have already highlighted. For K have 19 proton numbers. Its electronic configuration have 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. Its inner electron is 1s2, 2s2, 2p6, 3s2, 3p6 as I have already highlighted it. So as you can see, the inner electron for K is more than Na. So when the inner electron is increased, the shielding effect also increases. So the shielding effect for K is more than Na. Let's take a look at the question given. The atomic radius of D block elements. D block elements also known as transition elements. I will take scandium from first row as an example. Scandium has 21 proton numbers. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. After I arrange it, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d1 and 4s2. In this condition, additional electron will added into the 3d electrons and 3d electrons will share the 4s electron. When electron is added, the number of inner electrons will increase. It will increase the nuclear charge and also the shielding effect significantly. When the 3d electrons shield the 4s, it will shield the 4s from the increasing nuclear charge effect. And here the result is ZeV, which is effective nuclear charge did not change much. So the answer for this question is 1 Roman, the effective nuclear charge do not change much. 2 Roman, the electron added into an inner d orbitals. While 3 Roman, the screening effect increase is false. So the answer is B, 1 and 2. Let's move on to the next question. Question number 6. Going down the group in the periodic table, 1 Roman, the electronegativity decrease. 2 Roman, the metallic properties increases. 3 Roman, case of cation formation increases. We should know when down the group, proton number will increase, where inner electron also increase, and there When proton number increase, ZEV also increase. And when inner electron increase, screening effect also increase. When ZEV and screening effect increase, atomic radius will increase too. When the protons increase, the more inner shells will become, and the more weaker the attraction between nucleus and electron. The electronegativity became lower, so the ionization energy also decreased. This could make the increasing ability for metals elements to lose their electrons to become more reaction. So, the atom lose electrons and became positively charged, which means it became cations. So, the answer for this question is number 1, electronegativity decreased, 2, Raman dimetallic properties increase, 3, Raman EZ of cation formation increases. So, the answer is D, 1, 2, and 3. Question number 7. The size of Na is greater than Mg2 plus is greater than Al3 plus. Which of the following explain the strength? 1, Raman effective nuclear charge increase. 2, Raman number of electrons are same but the number of protons increase. 3, Raman the number of electrons and protons increase. So, Na, Mg, and Al is isoelectronic species is because they have the same electronic configuration. I have already stated Na2 plus, Mg2 plus, and Al3 plus electronic configuration. As you can see, they have the same electronic configuration. As we have studied, from the electronic configuration, we can know where all these elements belongs in the periodic table. For example, Na is on period 3, block S, group 1, while Mg is on period 3, block S, group 2, and Al is on the period 3, block P, group 13. If we look at the periodic table, Na, Mg, and Al is on the same period. When across a period, the protons will increase, while ZEV also increase, but electrons will remain the same. So, the answer for question 7 is 1, Raman effective nuclear charge increase, 2, Raman the number of electrons are same but the number of protons increase. But the third Raman, the number of electrons and proton increase is wrong. So, the answer is B, 1 and 2. Let's proceed to the question number 8. The graph shows all the successive ionization energies of an element P. So, from the graph, you can get 16 electrons, which is element P is 1s2, 2s2, 2p6, 3s2, 3p4. Again, from the electronic configuration, we will get element P is from period 3, block P, and group 16. So, choose the correct statement. 1, Raman P is expected to form a basic oxide. This is wrong because element P is an acidic oxide. Raman 2, P is formed in the third period of the periodic table. This is true because from the electronic configuration, you will get element P is from period 3. And the third Raman, the electronic configuration of P is 1s2, 2s2, 2p6, 3s2, and 3p4. We can see as the electronic configuration that we have stated earlier. So, the answer is C, 2 and 3. That's all from me. Thank you.